Programming language. So just like take an example in the real time. The Prime Minister of India wants to explain about national education policy for Telugu people. He has visited, let us say, Telangana state. The Prime Minister of India knows only a Hindi language, right? But Telugu people only knows Telugu language. Then while he is coming to Telangana state, he is going to bring a person called as translator, right? The person is going to have the knowledge of both Hindi language and Telugu language. So whenever a Prime Minister of India gives the speech, right, for the Telugu people, the person is going to understand, translator, in first Hindi language, and then he is going to convert into Telugu language for understanding Telugu people. So similar to that, a compiler is going to act as a mediator between the human beings and the computer system. So whatever the input you are given, which is in the form of English, that is being converted into mission understandable format. For all the languages, whatever you take, maybe Java, C, C++, or any language, it has to be converted into mission understandable format, right? So this is going to be done with help of compiler. Today, our expert, Dr. Kiran Kumar, who is having a huge experience.
For a minute, I was in dilemma whether they invited for guest lecture, but Dr. Lakshmaya started giving lecture on compiler design. Yeah, that's great. Fine. As you rightly said, one word in the end, like true compiler, true computer science person is one who knows a compiler and automata. Not now, like maybe way back in 15 years back, that was a story. But frankly, let me submit myself. Compiler is not order of the day. Okay, your data science is the order of the day. Okay, IoT is the order of the day. Okay, machine learning, all these domains are order of the day. Okay, you are very lucky enough that you joined like different courses in computer science, like pure computer science or computer science with the data science, computer science with IoT, computer science with machine learning. Anyhow, we'll detail discuss about different parsing techniques in the compiler design, definitely. And wish you all the best for your end career also. Thank you. And we'll continue in the lecture afterwards. Yeah.
Basically, context-free grammar contains four things. We say it's a four tuple, J equal to VTPS, where V is set of variables, T is set of terminals, and S in V start variable, and P set of productions of the form A to alpha. Okay. What is A? A is any variable, and alpha basically belongs to V plus the whole. So that means alpha is any string with variables and terminals. So you will be having, in a context-free grammar, you will be having four things: variables, terminals, and out of many variables, one variable is the start variable, and productions you have, it will be of the form A to alpha. That means left hand side always it must be a single variable, and right side could be any string with variables and terminals. And this is the basic mathematics for any parsing activities. We use context-free grammar in the background. Okay, yeah. For example, you take this. So this is one of the popular example normally you find in any compiler textbook. So if you take this context-free grammar, okay, this is basically equal to E plus T or T. E has two productions and T has two productions, and F is also have two productions. So here E, T, F are the variables. We call them as the variables, and remaining all are terminals. Like plus is a terminal, star is a terminal, left parenthesis is a terminal, right parenthesis is a terminal, ID is a terminal, and so on. Okay. Now basically the purpose of this context-free grammar, if you see, it is meant for, identifying any arithmetic expression. Any arithmetic expression which contains the arithmetic operators plus and star. Okay, so that means you take any expression, something like A plus B star C, or A plus B star C plus D. So you take any arithmetic expression which contains only two operators plus and star. This grammar is going to verify is it as per the syntax or not. Suppose if you write A star plus B, Just listen here, A star plus B. Is it valid syntax, A star plus B? Obviously no, because whenever there is a binary operator should be preceded and succeeded by two operands or one operand, right? So here, so this grammar basically checks whether your high level language, okay, is it as per the regular syntax or not? Especially when it involves the operators plus sensor. This is one of the most popular example normally you find in any textbook, especially a compiler design textbook by Aho and Woolman. Okay, or any other textbook also you find this example. Okay, so in major discussion of our complete today also we take this example more number of times, this contextual grammar. Yeah. Now there are whenever there is a grammar, so what grammar will be doing? Grammar basically derives strings of that particular language. Okay, I already told you that grammar is meant for deriving any string with the arithmetic operators plus and star, something like id plus id star id, or id star id plus star id, maybe some expression maybe in the parenthesis and so on. Okay, now here we are going to discuss an important topic called, maybe you get an examination also, they give a grammar, okay, and they give a string. So perform leftmost derivation, rightmost derivation, and write the parse tree for the given one. Okay, so this kind of questions like more frequently you'll be getting in the examination also. Okay, so how you do it? Okay, now see here, it is id star id plus id and id plus id in the parenthesis, which means id plus id has more precedence than star. Normally you know that when you have star and plus, which has more priority? Star has more priority, right, when compared to plus. But suppose if you want to give more priority to the plus, we keep that expression in the parenthesis, right? So here, so that means id plus id has to be evaluated first, then followed by, then the multiplication has to be performed. That is the meaning of that expression. Now let us see how I do leftmost derivation for that particular string id star id plus id, where id plus id in the parenthesis. Okay, basically what is this leftmost derivation means? I take the productions of the start variable, okay, and I keep on expanding the expression, and when I do expansion I always replace the left hand side variable only. Okay, if I replace always at each iteration, at each step, if I replace with only the left hand side variable, then we call that as leftmost derivation. Okay, now if you see here, my target is to derive the string id star id plus id. Okay, now any string if you want to derive, you should start with the start variable. So in this context, we have three variables, right? What are the three variables? E, T, F, right? So this is the grammar. This is the grammar we considered. Okay, E, T, F are the variables, and in this the start variable is E. Okay, so any string if you want to derive, you should consider E productions only. Now how many E productions are there? How many E productions are there? Two, right? One is E to E plus T is one production. It is vertical bar means R. Okay. E to T. E to T is another production. Okay, so there are two productions. So any string if you want to derive, either you start with E to E plus T or E to T only. No other. You should not start with the productions of T. You should not start with the productions of F and so on. Okay. So now to derive this id star id plus id, where id plus id in the parenthesis, so I started with E production. The first one is E to T. Okay, then T, you have to note down this, otherwise you can't understand. Students, you are informed to note down this grammar in your notebook. Okay, E to E plus T or T. T has two productions, T to T star F or F. And F has two productions, F to left parenthesis, E right parenthesis, or F to ID. Okay. Production T to F. Then see the expression F star F. At some stage you have F star F, right? So again in the leftmost F, I have replaced with ID. Why? Because we have a production called F to ID. Please see, there are 6 productions in the grammar. Okay. So therefore, up to this I got ID star F. ID star F. Okay. Now ID star, in place of F I am using this production. F to left parenthesis, E right parenthesis. So therefore F is replaced with left parenthesis, E right parenthesis. Okay. Then this E is replaced with E to E. It's something like puzzle only. Nobody will tell you which production has to be taken. Okay, so you will be given a grammar, you will be given a string, then you should try to derive that given string on your own, saying which production is more suitable. Okay, so in place of E, I have taken E to E plus T. Why I have taken E to E plus T? Why not E to T? Why? Because I need, after this, I need in the parentheses ID plus ID. So possible if I take E to E plus T, so this is giving that structure. Plus I have. So therefore, I have taken E to E plus T. Then this E is replaced with T because I have a production E to T, right? Then this T is replaced with F because I have production T to F. Okay. Then this F is replaced with the ID because I have a production F to ID. And here I have, in this expression, there is only one variable T. So this is replaced with F because I have a production T to F. And this is finally replaced with ID because I have a production F to ID. So finally, the required string ID star ID plus ID is derived. And if you observe carefully, what is the main important point to be noted is, at each step of my derivation, I have used only the leftmost variable, production. So that is the reason it is called a leftmost derivation. Why leftmost derivation we are discussing all of a sudden? Our target is parsing techniques. I will tell you the reason. Because parsing techniques, basically there are two types: top-down parsing and bottom-up parsing. Okay, all top-down parsing techniques, basically they mimic or they imitate the leftmost derivation. So once you understand what is leftmost derivation, you take any top-down parsing technique. I'll tell you there are many top-down parsing techniques. So they basically imitate, they mimic the leftmost derivation. Okay. So this is how we do leftmost derivation. So what we do in the leftmost derivation, we derive the string where at each stage we expand the leftmost variable and we replace the corresponding right hand side of the production. Okay. Now let us see what is this rightmost derivation. Rightmost derivation. So rightmost derivation, like, I just keep on expand the string until I get the required one. But at each step of my derivation, I always replace with the rightmost variable. So that is called rightmost derivation. Okay. Now see here, the same string ID star ID plus ID. Now I want to perform rightmost derivation. All of you with me? Understanding? Yeah. So ID star ID plus ID. Now that is the same string I have taken, but this time what I am doing? I am not doing leftmost derivation. I am doing rightmost derivation. Okay. So what I have taken? Again I have taken E to T, first production, where E is the start variable. Why? Because we already know any string if we want to derive, we need to start with the what? Start variable productions. Okay. So therefore I have taken E to T. Then of course T is replaced with the T to T star F. Okay. Now see the second expression, T star F. Now when I have T star F, there are two variables, right? What are the two variables? T is one variable, F is another variable. Now what is the rightmost in that? F. So I need to replace F, not T. So that is the reason if you see here, if you see there, the third step, F is replaced with its corresponding production. T is as it is. Why? Because in the T star F, T is the leftmost variable and F is the rightmost variable. And in the rightmost derivation, at each step, we always expand the rightmost variable only. Okay, so therefore, F is replaced with left parenthesis E right parenthesis. Now, again, you see this expression T star left parenthesis E right parenthesis. Again, there are two variables in that expression. What are the two variables? T and E. And again, here E is the rightmost variable. So therefore, E is replaced with E plus T here. E. T is as it is. This E is replaced with E plus T. Okay, E is replaced with E plus T. Now in this expression, again, there are three variables, right? T, E, again T. Now what is the rightmost variable? This is the rightmost variable. So this is replaced with this is replaced with F, T to F. T to F is used. Okay. Again, here also there are three variables, T, E, F. and this f is rightmost variable, and this is replaced with id. F to id production is used. Okay, now at this stage again there are two variables in this expression, t, e. Of course, this is terminal, and this is replaced with e to t. Again the two variables. This is the rightmost variable. This is replaced with f, and again there are two variables. F is replaced with id. Okay, and of course in this stage there is only one variable. This is the leftmost or rightmost. So then t is replaced with f. See the corresponding production, and f is replaced with id. Ultimately, I got it. Okay, thank you. Yeah, ultimately I got the required string id star id plus id. I got it. Okay, but what is the difference between the earlier one and the present one? Anyone? What is the difference between slides move over, no? Slides back front. Admittedly. Correct. Okay, so in this derivation, at each step of my derivation, I have always used the leftmost variable. So that is the reason it is called leftmost derivation. Whereas in this derivation, at each step of my derivation, I use the rightmost variable production. So therefore it is called rightmost derivation. Okay. Now why only leftmost derivation? Why not is any derivation random? Of course you can do it, but as I told you already, there are two types of parsing techniques, top down and bottom up. Top down basically imitates leftmost derivation, and the bottom up imitates, any guess? No, it's not rightmost derivation. It is reverse of the rightmost derivation. Okay, any bottom up parsing technique. You have SLR, LR, CLR, or operator precedence. So there are many bottom up parsing techniques. All bottom up parsing techniques, they imitate reverse of the rightmost derivation. Okay, when you have one special technique called LR technique. LR is basically bottom up, where that R in LR, R represents what? Rightmost derivation in reverse. That R represents what? Rightmost derivation in reverse. So therefore, in general, any top-down parsing techniques, they imitate leftmost derivation, and any bottom-up parsing techniques, they imitate rightmost derivation in reverse. So this is the bottom of the point. Now we have one more called parse tree. Why? Because so that with this parse tree, I can verify whether the high-level language that you have written is syntactically correct or not. For example, let's say there is an expression a equal to b plus c semicolon. The C language you write. Okay, let's say you are writing a small program to add. After this f is replaced with what? Left parenthesis e, right?